Hi everyone, welcome to this video on lesson 4 of the Earth and Climate scheme of work. This lesson is on igneous rocks and it's really building on what we did in the previous lesson, which was looking at constructive plate boundaries and what happens in places like the Mid-Atlantic Ridge. Now I think it's really important before we get onto our diagrams and stuff like that in this lesson, get some rock samples out. So I've got a box here which I can put under the visualizer, so I'm sure in your prep room or somewhere you'll have a big box like that, and I've got a few examples of igneous rocks here which I'm going to go through. And what I would be doing is firstly make sure you've got hand lenses, so you can see a hand lens here, and I would be showing students how to use a hand lens. And I can actually demonstrate it under the visualizer as well, but in class with students, I'd be literally showing them, okay, so I put the hand lens near to my eye, you have to do the kind of pirate face and close one eye, and then what I'm going to do is bring my rock closer to that until it's in focus, and then I'm going to have a look at this structure of it. And what we can do is show them a few examples of igneous rocks. So the first one, the one that I've got in my hand at the moment, is basalt. So I'm going to try and bring this closer in the same way. Hopefully, annoyingly, in this room it's just gone a bit dark. But if I bring that closer like that, hopefully what students will be able to see, I appreciate it's not mega clear on this video, but what you want to point out to them is that basalt, it's black, obviously, or this one's kind of dark grey. And if they look closely, they should be able to see some very tiny crystals. I've got another example here. This is, I need to remind myself, it's either gabbro or dolomite. Oh, sorry, dolerite, I'm not sure. But anyway, if I bring this close, what we can show them, and if you can do this under the visualizer, that's great, but I mean, even better, just get them to have a look. What they should be able to see, if you've got the lighting right, which I don't appear to have in this room, if you've got the lighting right, is that, there we go, we're starting to get something. Yeah, there we go. We can start to see some crystals in here. If I can get that focused like that. So we can see some crystals on the surface of this rock. These are quite small crystals. And then you can compare that with some granite. And what you'll see with granite is that actually, there we go, the crystals are quite a bit larger. And they're all, there's some nice shiny ones as well, and kind of different colours. So there's a lot of interesting stuff going on. So one thing that we want them to notice straight away is that these igneous rocks typically contain crystals. We will talk about obsidian as well. I don't have an obsidian sample, but that's slightly different, but formed in a similar way. So they've got crystals. So we want to understand, well, why that is. And again, this is a nice lesson because it's really not introducing anything new, it's just building on what they learned about in the previous lesson. So this is where I'm going to come back to a diagram. So I've got my, again, very rudimentary world map on my globe here, and I'm going to just sketch again the Mid-Atlantic Ridge, which kind of goes something like that down the middle of the Atlantic Ocean. And again, I can draw their attention to Iceland here, like this, up there. And what I want to do is say, well, okay, at the Mid-Atlantic Ridge, if I were to, again, take a bit of a cross-section here and look at what it looks like, something like this, just at the Earth's crust, or the kind of crust-mantle boundary, so I'm not going to do the whole cross-section down to the Earth's core here, just looking around the crust and the mantle. What I see around the Mid-Atlantic Ridge, and we talked about this in the previous lesson, is earthquakes. So I'm going to just draw a few earthquakes here like this. So let's do earthquakes, I beg your pardon, volcanoes. I see volcanoes, so I'm going to draw a kind of volcano like that, and some just little hills, and then maybe one of those Icelandic volcanoes that's less steep. This is going back to some geography now, isn't it? And you get the different types of plate boundary, you get the different shape of volcanoes, whatever. But the point is, you get some volcanoes here like this, and underneath here, so that's the crust. It's not going to be a perfectly straight line, I'm sure, but underneath here, I'm going to leave a couple of gaps where the volcanoes are. But you've got the mantle under here like this, and obviously magma is moving around here, but we've got some exit routes for the for magma from the mantle at the point of these volcanoes. And what we want to emphasize to students is that there's essentially three ways that magma can exit the Earth and cool to form igneous rocks. And I don't know whether I said this. This is really, really important. The point we want to make is all three of these, and obsidian as well, we can talk about in a sec, they're formed by magma cooling, and that is why you get these characteristic crystals. And I'm going to show how they form in different ways. So what we can do first is look at what happens if you get a really violent volcanic eruption like this. There you get, I'm going to try and show this in a diagram here. There you get this kind of instant cooling like this. So you get rapid, let's show here, you get a rapid rise, and I'm going to show that rapid rise by a really long arrow here. So you get a very rapid rise and exit from the Earth, and therefore you get rapid slash, I'm even going to put instantaneous. It's not a word I can spell while talking on the video, instantaneous. Rapid slash instantaneous cooling. And if that happens, then you get this kind of glassy structure, which is essentially not really got any crystals at all. And again, I don't have any obsidian with me, but you can kind of sketch that glassy structure like this. But again, the best thing is to, if you've got a sample, but this would be obsidian, where you've got no crystals formed at all. And that's formed because it just literally instantly, I think it's called petrification, but again, I would have to check with an expert on this, but that kind of immediate glassy structure is because of the immediate cooling. There's another case where you can get this sort of slower rising and this slow kind of oozing out of magma into lava. So that's going to be my second case here on this volcano. So if I label this here, we've got, I'm going to put this as relatively fast cooling. So it's not this kind of instantaneous flash cooling, but it's risen a bit fast. It's risen reasonably fast, and it's cooled sort of relatively fast as well. Now, if it cools relatively fast like that, then we end up with these rocks like basalt, and I'll sketch this in black here, which if we zoom in, they've got these very small crystals. And again, it's really important that students see this through their hand lens, that the crystals are there, they're just very, very small. So I'm going to sketch these very small crystals and link that to the kind of quite fast, but not very fast cooling. And this is characteristic of basalt. And again, what you can emphasize to students is, well, you get loads of basalt around Iceland, because Iceland is full of these kind of shallow volcanoes where magma is rising at the constructive plate boundary, and then it's cooling quite quickly. It's not really forming these big crystals, and that's why you get this structure. And then the last thing we can get happening is magma kind of gets stuck, and actually I might just rub this part out. You get these kind of almost like reservoirs where magma kind of gets stuck and it can't move anymore, and it cools very slowly because it's near the crust, but it's not really moving out to the Earth's surface. So in this case, if I do my final arrow, this, I can show that you've got very slow cooling here, slow cooling. And if you get slow cooling, and it's kind of very slow rising as well, well, slow cooling, and again, in year 8, we're not going to go into the detail of why this is, how cooling rate relates to crystal size, but what we can tell students is this is why you get these kind of bigger crystals inside the rock like this. So I'm going to draw these bigger crystals here, and if we zoom in, we can say these are bigger crystals drawing it something like this. And again, all we're doing at this stage is just linking this idea of cooling rate with the size of the crystals. And this is characteristic, a bit like this one, of what we saw in granite. So the reason you get these different sized crystals, or these larger crystals I should say, in granite is because it's cooled more slowly. And what's interesting then is that you can relate that back to our picture of the Earth. If I just zoom out a bit, so that's all in here. So Iceland is full of basalt because that's happening all the time as we speak. That actually magma's rising and it's cooling relatively quickly, and it's forming this new rock with quite small crystals. We've got lots of, we do have some basalt in the UK as well, but actually we've got quite a lot of granite as well. It's worth emphasising that because of Wegener's theory of continental drift, well, actually, we were once on a constricted plate boundary. There were once volcanoes and stuff around the UK, or what is now the UK, but obviously that's moved away, so we don't have any volcanoes anymore. But we got these big pools cooling slowly underneath the Earth's surface. And that's why, if you go to Devon and Dartmoor, where lots of Greenshaw Learning Trust students will have done the 10 tours and things like that, you can see the rocks up there are mostly granite, and that's because they formed by this slow cooling process. So you can kind of relate it back to the world that's actually around them. And then, yeah, obsidian, that's rapid cooling, and yeah, if you've got an example of that, you can show them that too. I think that's it. I feel like there was something else that I wanted to say in this video, but my mind has gone blank. Hopefully that's clear, and in the next lesson we will start to look again. We'll look at the next part of the rock cycle, which is to do with weathering and transportation.